previously I have discussed something about how analog computing and digital computing happens within a single neuron. So, the discussion was in a single neuron, but there are some technical terminologies which I would be to see in biological terms it is called as spatial summation and temporal summation. Okay, graphs again. Spatial summation is simple. So, simple in the sense that you have signal here, measurement here. So, when you have signal here, we assume that both of it is positive and we assume that both are EPSP. So, we need to clarify that EPSP, and then this is a axon, these are dendrites. So, axon, dendrite, and how stimulus differs from with both. So, in the first case you have signal coming through minus 70. So, you need minus 55, which is the threshold for activation potential. I will start with the second graph because the first graph is pretty obvious. Minus 70, 55. So, both of these are EPSP. So, EPSP, what happens to the axon in the in case 2? Case 1. So, in this the first signal, which is the EPSP over here, which is a small current which is generated over here, it does not reach the threshold required for activation. We will label it as around plus 20. So, then there is a 20 which happens because this is closer, then it comes down. The subsequent 20 comes at a later point of time. So, you have only two small EPSPs which have changed when there is no action potential which is generated at the in the axon, no signal gets transmitted. Same two EPSPs which are here. So, the first EPSP is generated and it comes up over here. So, and the second EPSP reaches up to 55 and that in turn triggers an action potential. So, this is the idea of spatial summation. Spatial summation is summation over space. Somehow nowhere in computer architecture, from semiconductor design, VLSI design to neural network design, is the concept of space incorporated. From all the diagrams which I have seen in terms of circuit diagrams or ANN designs, the idea of incorporating space or distance as a method of computing somehow does not exist. Everything is paper based, 2-dimensional, and has a very 2-dimensionish problem to the whole of the engineering side. The nervous system in this is, I have just drawn line diagrams and I am pretty sure somebody would be inspired to work it out in greater detail. As to the richness of incorporating space is a hyperparameter. So, space would give an entire new dimension to a lot of electrical, electronic design and maybe even neural networks. See, neural networks are still designed on paper. You have 2-dimensional neural networks which are built. Convolutional neural networks of course use channels, but essentially the computational thought is 2-dimensional. The neural networks, or even this is not even a neural network, this is one single neuron which we have been discussing so far. A single neuron uses space as a method of computation, richly analog, and generates this kinds of differing graphs, which is obviously information processing. This is about spatial summation. We will go into the next one with the same logic to explain temporal summation. So, temporal summation is a little more easier to explain, because it's so stimulus here is at similar points, EPSP again. So, we will do plus, sorry, I think I mixed up. No, spatial, it is spatial, yes. So, it is a plus 20, and this is also a plus 20, but there is a time delay for this stimulus over here, and here again you have plus 20 and plus 20, 40, 70 minus 40 is plus 30. So, minus 70 minus 70, and we draw the graphs. Minus 70. So, what happens? You have the first 20 coming up sometime, and then there is a delay for the other 20 to come, and so that does not cause anything, and then there is a straight line. Here you have minus 70, both come at the same time, and that produces a single, sorry, it produces a single action potential. So, spatial summation, this is temporal summation. This is biological theory. So, basically what temporal summation is discussing about is phase of the signals, how phase integration is useful for information processing, and that's the notion of spatial and temporal. Spatial is because two things are separated by a distance. Both of them start at the same time, but arrive at different times because of the spatial separation. In terms of when it is in both, of course, logically, yeah, there may be somebody who would argue that ultimately it is the same, and that is why we have been so brilliant that we put everything on 2 dimensions and work out. That is one way of looking at it. But spatial computing is a very unique property. It is a 3-dimensional, rather 4-dimensional computing which the nervous system does, 3 dimensions and 1 in time. So, 4-dimensional computing and analog ionic computing which is done by the nervous system to do various kinds of information processing. So, in the past couple of minutes what I have discussed is how same signals, digital signals, get converted into analog. So, you have unitary quanta of vesicles delivered by unitary action potentials into dendrites, but just they differ in either space or length of travel. They produce different outputs, and how it is feasible is shown over here. The technical terminology is different, but I think the understanding which has to go is how these two are very powerful concepts which the nervous system has harnessed to do its rich information processing. Also a hidden message or a very obvious message to people who are interested in the discussion to continue this work and explore new possibilities in semiconductor to ANN and CNN research. Thank you.